Hey there, and welcome to this explainer. Today, we're going to look at something you probably plug into the wall every single day. We're going to demystify that tiny box that safely powers your smartphone. Inside that little block, electricity is completely changed, it's controlled, and it's made perfectly safe. It's really a wonderful piece of everyday engineering. So we're going to learn exactly how it works step by step. No complicated theories here, just simple electronics that absolutely anyone can understand. Let's get right into it.
Okay, let's dive in by thinking about the main problem we have to solve here. The electricity living inside your wall socket is completely different from what your delicate phone needs to survive. The power in the wall is incredibly strong, but the power your phone needs is actually very small. So how does this little charger safely handle that massive difference? How does it bridge the gap without just totally frying your device?
Well, our journey starts right at the wall socket, which brings us to our first major hurdle, the high voltage problem. You see, the electricity coming out of your wall is what we call alternating current, or AC power, and this AC power has a very high voltage. Because it's so strong, it's actually pretty dangerous for small, delicate electronics. Let's think about this like water flowing through pipes, right? Imagine your wall socket is a high-pressure fire hose. The water is just blasting out with incredible force. Now, imagine your smartphone is a tiny, delicate water glass. It really just needs a gentle, quiet trickle to fill up. If you point a blasting fire hose directly at a small glass, well, the glass shatters completely. If we connect high-voltage wall power directly to your phone, the battery would be completely destroyed. The charger has to fix this.
And that brings us to step one, stepping down the power and reducing that intense pressure. Inside your charger, there's a special component called a transformer or a switching circuit. Its entire job is to step that high voltage down to a much lower, safer level. It literally transforms the big, dangerous power into small, manageable power. This step is absolutely crucial because your phone only works on low voltage. Without the transformer, the whole process just stops right here. So the high pressure has now become a manageable pressure. That massive fire hose has been dialed down to a much smaller, safer flow. To summarize our first key idea, the transformer lowers the voltage to protect the phone. But, we actually still have another big problem to solve.
Which leads us right into step two, AC to DC conversion. Remember how the wall provides AC, or alternating current? That means the electricity literally flows back and forth, kind of like waves crashing on a beach. But your phone's battery can't drink wavy water. To fix this, the charger uses a really clever component called a rectifier. Think of the word rectify, which means to set something right. It forces that wavy AC power to stop bouncing around and lines it up so it flows smoothly in one straight direction. So a wavy flow becomes a one-way street. This is called DC, or direct current. Electronic devices can only use electricity that flows steadily in a single direction. By making this AC to DC conversion, the rectifier has finally made the power actually usable for your phone. So repeating this key step, the rectifier turns AC into DC, making the electricity flow in one straight line. Now we move on to step three, smoothing and regulating. We have low pressure and a one-way street now, but we aren't completely safe just yet. Even though the electricity is now flowing straight, it's still a little bit bumpy. That conversion process leaves behind small fluctuations. To smooth out these bumps, the charger uses components called capacitors. Going back to our water analogy, imagine the water flowing through the pipe is kind of pulsing. Surge, drop, surge, drop. Capacitors act like little holding tanks placed right along the pipe. They catch those sudden surges of water and they fill in the drops. Because of these tiny energy buffers, a perfectly smooth, stable stream of power comes out the other side. And now comes the most important part of the whole operation, the final check. A tiny chip called a regulator acts as the ultimate gatekeeper. Even with that smoothing we just did, power can sometimes jump unexpectedly. The regulator ensures the output voltage stays completely constant. It makes absolutely sure there are zero dangerous spikes that could slip through and hurt your battery. Usually this regulator locks the output safely at a constant 5 volts, or if you have a newer device, it locks it at the exact fast charging level your specific phone asks for. 5 volts is that safe, gentle trickle of water that perfectly fills up your smartphone's glass. So, to summarize step 3, capacitors smooth out the bumps, and the regulator locks in the exact safe amount of power. And that beautiful, clean electricity brings us to step 4, safe power for your phone. The hard work inside that tiny box on your wall is officially done. This perfectly clean, low-pressure power travels down your USB cable and finally reaches your device. Once the electricity is there, your phone actually takes over the charging process. Your phone is incredibly smart. It uses its own internal battery system to manage the rest, deciding exactly how much of that clean power to let into the battery at any given second. So, to quickly recap everything we've learned today, your simple phone charger is actually like a multi-stage factory. First, the transformer reduces the dangerous high pressure. Second, the rectifier makes the wavy power flow straight. Third, capacitors smooth out the bumps. And fourth, the control chip regulates the flow safely at exactly 5 volts. It's just a tiny device, isn't it? But as we've seen today, it's packed with incredibly powerful electronics. They are doing an amazing, complex job to protect your phone every single time you charge up. Without these 4 steps working perfectly together in just a fraction of a second, our modern mobile lives literally wouldn't be possible. So I'll leave you with this final thought. Next time you plug your phone into the wall, will you pause for just a second to appreciate the tiny, powerful electronic factory working so hard inside that little box? Thanks for learning with me today.